I guess you could consider this a word problem for a quadratic function, parabola, in other words. One thing to notice about this is it actually gives you the function setup. All you have to do is plug in the information and solve it. So technically it's really not a word problem where you have to design the function. Alright, in this case you might also want to notice that it's a negative 4.9 sitting out in front of this t squared. That means this parabola, we know for sure, is going to be an upside down facing one. So if this is the height of an object off the ground vertically, of some object being thrown into the air, then eventually it's going to reach this maximum height. It's also going to start off someplace and it's going to end up back at that same place. We're going to call that the ground. So this function is only talking about some object going up and then coming back down, and how far off the ground it is at each second after its initial takeoff. In this formula, v sub 0 stands for its initial velocity. How fast was it going right when it took off from the ground, or from the gun, or from whatever it is. S sub 0 is your initial height off the ground that the object was propelled from. Alright, in this case we're looking for the maximum height of something that was propelled from the ground, has an initial velocity of this 18 meters per second. Also we'll want to find out when the ball hits the ground after it is in motion. How long does it take? Alright, so this first thing is 18 meters per second is a velocity. It's the initial velocity. After this initial velocity takes effect at that instant, gravity starts slowing the object down. So it's not always going to be this 18 meters per second. That's going to go into this v sub 0. Now s sub 0 is not explicitly stated here, but it does say this thing is starting off from the ground. So s sub 0 must be equal to, well, 0 if it's 0 meters off the ground. Alright, so let's set up our function. This becomes s of t is equal to negative 4.9 t squared. V sub 0 is equal to this 18 meters per second times t, and s sub 0 is just 0, so I'm just going to leave it off. Alright, so how do I find this maximum value, this maximum height off the ground that this is going to be? Well, that looks a lot like a vertex, so I'm going to use the axis symmetry formula to find the vertex. So here we're going to say t is equal to that negative b over 2a, and in this case b is the coefficient next to t, so that'll be 18, so it'll be negative 18 over 2 times a, and a in this case is this negative 4.9, which is half of the acceleration due to gravity. Thought I'd throw that in there. This comes out approximately as 0.82. So after 0.82 seconds of flight, this object is going to reach its maximum height and then start its return journey to the Earth. Alright, to find exactly how high it went, we're going to plug it into our function. S stands for distance. We're going to plug it in for t. So we're going to put in this 0.82. And this becomes negative 4.9, 0.82 all squared, plus our 18 times 0.82. And typing this into a calculator, you're going to end up with 3.3. Now this 3.3 is the distance off the ground, and since we're dealing with meters per second, this must be 3.3 meters off the ground. So about 9 feet, maybe about 10 feet of height. Now this last question, also find when the ball will hit the ground after it is in motion. If you're going to hit the ground, you're going to be 0 feet off the ground. So we're going to get 0 is equal to negative 4.9 t squared plus 18t. And to solve this equation is actually kind of easy. You factor out a t. So we're going to get 0 is equal to t times negative 4.9t plus 18. It's really nice when it starts off at the ground. We don't have that last number to worry about. If it was there, you'd have to use quadratic formula. But in this case, we can use our little factoring. So one of my answers is going to be t equals 0, which makes sense. our motion started with the object on the ground. The other one is going to be negative 18 divided by negative 4.9, approximately 1.6. So after 1.6 seconds, remember this is t, the object is going to come down and hit the ground. So it'll go up, get out of the way, 1.6 seconds it'll come back and hit the ground. And that's it.